Who was Galileo Galilei? What if someone told you that the ground beneath your feet was actually moving? You'd probably laugh in their face because you know the ground doesn't move. Well, that is unless you were alive 400 years ago when the world was still trying to figure out how it worked. Back then, it was generally accepted that the Earth was the center of the universe and everything else went around it. This belief was so widespread that there wasn't even a word in the English language to describe the other possible arrangement, so people just described it as heliocentric, meaning sun-centered. It wasn't until much later that we started calling it heliocentrism. So now back to our story. In this time of geocentrism, there lived a man named Galileo Galilei, who was born in Italy in 1564. Galileo was a brilliant scientist and one of the first people ever to use mathematics to describe how nature works. But what made him truly special was his willingness to challenge long-held beliefs with evidence and experiments. And because of that, he ended up changing the course of human history forever. He dared to believe the Earth revolves around the sun, that humans are just a small part of something much larger, and that everything we see in the night sky is just as comprehensible as the things around us here on Earth. And it was this belief that led him to make some of the most important discoveries in human history. Before we get into what those discoveries were, though, let's talk about the instrument that made them possible, his telescope. In 1609, Galileo heard about a new device that had been invented in the Netherlands called a spyglass, which could magnify things that were very far away. And he immediately thought of its potential application in astronomy, so he set about building one of the first astronomical telescopes. When it arrived, he took it to a rooftop in Padua where he lived and pointed it toward the sky. What he saw shocked him. With his telescope, he could see that the surface of the moon was covered in craters and mountains. This was the first time anyone had ever seen such detail on the moon, and it completely shattered the old belief that the sky and celestial bodies were perfect and unchanging. He used his telescope to see other things no human had ever seen before. With it, he observed the 4 largest moons of Jupiter, which today are called the Galilean moons. And he saw that Venus went through phases like the moon, which at the time was used as proof that Venus orbited the sun rather than the Earth. All of these observations were recorded in his book, Sidereus Nuncius, which was published in 1610. Overnight, it made Galileo famous. People all over Europe were talking about his incredible discoveries, and the rest of his life would be dedicated to making even more groundbreaking discoveries and defending the Copernican theory against his contemporaries who still believed in an Earth-centered universe. His next major discovery came after he built an even more powerful telescope. In 1613, he spotted a small dark spot on the surface of the sun, which he correctly identified as a sunspot. From this, he concluded that the sun was a real physical object rather than a distant, unchanging, perfect orb of fire. He also made detailed observations of Saturn, Mars, and Neptune. He tracked comets, investigated meteor showers, and measured the diameter of the moon. Galileo was able to make all of these discoveries despite often being blind. For most of his adult life, he suffered from a condition known as myopia, which caused him to lose most of his eyesight by the end of his life. However, it didn't stop him from continuing to observe the stars. But Galileo didn't just want to collect cool facts about space. He wanted to explain how everything worked, and that led him to conduct experiments on Earth. One of the most famous was his experiment on the Leaning Tower of Pisa, in which he supposedly dropped 2 balls of different weights from the top of the tower to see if they fell at the same rate. Contrary to popular belief, however, he almost certainly didn't drop 2 balls of different weights, but rather just 1 ball multiple times. Still, the results of his experiment showed that all objects fall at the same rate, regardless of their weight, which was revolutionary at the time because the prevailing belief was that heavier objects fell faster. He also did experiments on motion, like rolling balls down inclined planes to better understand gravity. And he built a more accurate pendulum clock, which was important because it provided a more reliable way of measuring time for scientific experiments. All of these discoveries and experiments were published in his book called Discourses and Mathematical Demonstrations Relating to 2 New Sciences, which was published in 1638. In it, Galileo explained how things move not just on Earth, but in space too. He said that everything in the universe moved in accordance with mathematical laws and that those laws applied equally to all objects. This was a completely new way of thinking about the world, and it marked the beginning of modern physics. But Galileo didn't just want to change the world with his science. He also wanted to change it with his writing. Throughout his career, he wrote many books and articles defending the Copernican theory and attacking his opponents. The most famous of these was the dialogue concerning the two chief world systems, published in 1632. In it, he presented arguments both for and against the heliocentric theory, but clearly favored Copernicus's view. This enraged the Catholic Church, which at the time was the most powerful institution in Europe and which still believed that the Earth was the center of the universe. They accused Galileo of heresy and summoned him to Rome to stand trial before the Roman Inquisition. The trial lasted only a few days and Galileo was found guilty. He was ordered to recant his support for heliocentrism and was placed under house arrest for the rest of his life. Even though he had been forced to recant, Galileo still believed that the Earth revolved around the sun. In fact, in the margins of his book, he wrote, "Minds created free by God must never be enslaved." He continued to make scientific discoveries and wrote several important works while under house arrest. But he never again published anything that could be seen as controversial. After Galileo died in 1642, the Catholic Church continued to suppress his work. They didn't allow his books to be printed until 1822, nearly 200 years later, and they didn't clear his name until 1992, when Pope John Paul II officially apologized for the way he had been treated. Despite the persecution he faced, Galileo's ideas spread throughout Europe and eventually the whole world. They inspired later scientists like Isaac Newton to make their own discoveries, and they helped establish the scientific method, which is a way of understanding the world based on questioning, testing, and observation, rather than just accepting what people say. The scientific method is still used today and is the foundation of modern science. Galileo was one of the first people ever to use mathematics to describe how nature works. He said that nature is written in the language of mathematics, and that to understand it we need to use math. He used math to predict how things would move and to test his ideas about the world. For example, he used math to calculate how fast objects would fall to the ground if they were dropped from a certain height. He also used math to calculate the circumference of the Earth. By using math, Galileo was able to make accurate predictions about the world around him and test his ideas about how it worked. This was a completely new way of thinking about the world, and it marked the beginning of modern physics. If you've watched any of our other videos, you know that we love to ask why. That's why our favorite thing about Galileo is that he didn't just accept what people said, he questioned it. He asked why the world did things the way it did, and then he tested his ideas to see if he was right. That's the whole point of science. It's not about memorizing facts or accepting what people say. It's about asking questions and finding answers through experimentation. So why do we still care about Galileo today? Because his curiosity and willingness to question the status quo changed the world for the better. He showed us that truth is discovered, not declared. And he laid the foundation for modern science. If it weren't for Galileo, we wouldn't have the smartphones, computers, and other technologies that we rely on today. So thanks, Galileo. Hey there, fellow viewers. I hope you've enjoyed this video as much as I enjoyed making it. If you found the content helpful, informative, or just plain entertaining, I've got a small favor to ask. Don't forget to hit that subscribe button. It's the best way to stay up to date with all our latest videos and content. But wait, there's more. If you really want to show your support, give this video a thumbs up. It helps us reach more people and lets us know what kind of content you enjoy. And last but not least, we'd love to hear from you. Drop your thoughts, questions, or suggestions in the comments section below. Your feedback is invaluable and helps us create even better content in the future. So remember, subscribe, like, and comment. It only takes a few seconds, but it means the world to us. Thanks for watching, and I'll see you in the next video.